Okay, everyone, so this is your question 8, and your question 8 there looks like that. I just drew it out myself here, and I put in a couple extra things. I just put in here, so you've got an output coming out of this gate here, and I've called it Q, and you've got an output coming out of this gate here. I've decided to call it P. It just might make it easier for me to do a bit of work as I'm going along there to have it shortened down to those little names. You've got gates here. This is the AND gate. The AND gate means for you, always remember the rule, both inputs must be true for you to get an output of true. So that means both inputs must be 1 for you to get an output of 1. Otherwise, you will get an output of 0, no matter what. And the NOT gate basically takes one input and gives you an output. And in this case, the NOT gate, whatever input you get the reverse of it out. So you get 0 in, you get 1 out. You get 1 in, you get 0 out. And the OR gate, like the AND gate, takes 2 inputs to produce an output. And the OR gate, the rule for it is, if either input is true, or both inputs are true, you will get an output of true. So that's your doorbell one. If you remember, press your front doorbell, it rings. Press your back doorbell, it rings. Yeah, who has a back doorbell? But I was just using that example to try and remember it. And the smallest house in the world, you press both of them together at the same time, the doorbell will ring. You know, so there's your example. Right, so moving from left to right. You always go from left to right. And I just throw in here as well, the logic expression of that half adder is as follows. So you break it up into 2 bits. There's the OR bit in the middle, which is the combination of all of this stuff. And have I'm missing a bit there, haven't I, as well? That's only for the top bit, to give you X. X is equal to that. Y then is just equal to A and B. Y is equal to A and B, so I missed putting that in there. But this top bit, so basically you have A and not B. So that's joined onto the B there. So A and not B. Or not A and B. And that's the logic expression there for the sum part of the half adder. The bottom part here is just A and B, and that's actually the carry. That's the carry there when you go to do it. So how does our truth table look like here? Well, here's my inputs, A and B. You always put them down first. 2 inputs. You've got to represent all you can using the digits 0 and 1. And you had little tips to remember from last year, but at this stage, you 2 inputs, you're going to have 0, 0, 0, 1, 1, 0, 1, 1. Job done. If you have 3 inputs, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. But I always told you the way to remember it is, the rightmost bit will always be your 0, 1, 0, 1. Next one will be 2 zeros, 2 ones. Next one will be 4 zeros, 4 ones. And then you'd repeat these back again. 2 zeros, 2 ones, 1 0, 1 1, and that kind of stuff. So, moving along. Right, figuring out some of this stuff. So we need a not A, because it's down below here somewhere. Yeah, not A, that's that bit. So you need a not A. So whatever the input is for A, reverse it. Whatever the input is for A, reverse it. Whatever the input is for A, reverse it. Done. You need the same here with the not B. So whatever B is, you need to get the not of it, invert it, so reverse it. So not B, 0 here, you get a 1. 1 here, you get a 0. 0 here, you get a 1. 1 here, you get a 0. Right, they're easy. Those 2 are easy. And now the next one I'm going to work out after that is this Q here, which is made up of A and not B. Because this is an AND gate, A and not B. So that's what Q is going to be. So A and not B. So there is A, that whole column there. Here is not B, it's this whole column here. And then you always do your rules first. AND gate. Both inputs must be true for you to get an output of true. So, here's 0, ignore it. Here's 0, ignore it. Here's a 1. Do I have a 1 here for not B? I do. So your output is true. And here's a 1. Oh, but I have a 0 here. No good. So 0. And the others then are just 0 by default or whatever. Both inputs A and not B, this fella here and this fella here, they must be true to get an output of true. So that's A and not B. The next one you have, going into the other AND gate, is not A and B. Not A and B. So again, you go up to your columns. Not A is all this fella here. I'll make these available to you, Archie, if you want to look up. Make these available to you. Not A, and then and B is, not A is there, and B is here. So again, AND gate. Both inputs must be true for you to get an output of true. So there we go with that one, 1 and a 1. We're going to get a 1. And here, 0 and 1, no good. Not both of them, so 0. 0 and 0, neither of them, 0. And only one of them is true here, but you need both of them for the AND gates, so that's 0. So that's P worked out. Now, working out Y. Very simply here, this is the carry. When you do a 0 and 0, you get sum of 0, carry of 0. When you do 0 and 1, you get a sum of 1, carry of 0. When you do a 1 and a 0, you get a sum of 1, carry of 0. And when you do a 1 and a 1, you get a sum of 0 and a carry of 1. And so watch out for that. Sum of 0 and a carry of 1. So this is our AND gate here, which is actually the carry in the half adder. So you end up getting A and B, quite simply. 0 and 0 is 0, and here they are. Here they're doing them. 0 and 0, you get a sum of 0, and you get a carry of 0. Now remember, this is the carry row. Watch this. This is the carry. 0 and 1, you get a sum. And this is the carry. You get a sum of 1 and a carry of 0. 1 and 0, you get a sum of 1 and a carry of 0. And 1 and 1, you get a sum of 0 and a carry of 1. So this is your carry in the half adder when you're adding binary numbers. Like you'd add, if you were doing normal maths there, 5 plus 6, 5 and 6 is 11, sum is 1, and you carry 1. So that's what we're talking about there. This is the carry when you're adding binary numbers, and that's Y there worked out. And then the last one is your OR gate, which is made up now of, if you want A and not B, or not A and B, but you've got them now labeled as Q and P, so it's just Q or P here. And look at, I just take it as Q or P now, much easier. Q or P, and in an OR gate, either input or both can be true to give you an output of true. So 0, and let's do the rule first. There's one of the inputs is true, so the output is true. There's one of the inputs is true, so the output is true. And there's one of the inputs, that's it. Both of them are false, so output of false. Both of them are false, output of false. And that is our sum. So let me do the sum and the carry now, right? This one is the sum, this one is the carry. 0 plus 0, sum of 0, carry of 0. 0 plus 1, sum of 1, carry of 0. 1 plus 0, sum of 1, carry of 0. And the last one, 1 plus 1 is 2 in our language, which in binary is 1, 0. So that gives you a sum of 0 and a carry of 1. And there is your half adder used to add binary numbers.